So in this video, we're going to look at exponential functions and graphs. We're going to start off by looking at, well, what exactly is an exponential function and how exactly do you sketch one? And then we're going to look at, well, how do you find the equation of an exponential curve given 2 points on the line? And then do the exact same thing, but this time we're not given the point at the intercept, like example 2. And then finally, we're going to look at, well, how do you find the value of a coordinate on an exponential curve? As always, we're going to wrap up with an exam question. So we're going to start off with the basics. So here we've been given some instructions to sketch a graph with the equation y is equal to 2x. So y is equal to 2x. Now this is an exponential curve. And the way I know that is because x, the variable x, is a power. Okay, because x is a power, this is an exponential curve. What that means is the curve is going to look something like this. Okay, it's going to start off on the left side, close to the x-axis, and as we go to the right, it's going to go up. It's going to rapidly grow. So this is called exponential growth here. Okay, so it's going to pass through the y-axis at 1. And I'll explain that in just a second. In fact, I'll explain that now. So you can see, well, at this point here, where it crosses the line, x is 0. So if x is 0, we can say that y is equal to 2 to the power of 0, and anything to the power of 0 is 1. So an exponential curve always crosses the y-axis at 1 when it's in this format. It increases rapidly on one end. So in this case, it's exponential growth, and it never crosses the x-axis. So just a few notes to make. Never crosses the x-axis. The second one is intercepts y-axis at 1. And third one is grows rapidly. So moving on, here's a few examples just to show you. So here we've got exponential curves, and on the left, if you start looking on these first, you can see they all follow a rough pattern like this. This is called exponential growth. And notice here, the value 5, 2, and 1.4 are all above 1. So you can sort of see when the value is 5, it sort of accelerates rapidly as it intercepts the y-axis. Then it sort of eases off when it's 2, and when it's 1.4, it's a bit more gradual. When the value is less than 1, so for example 0.1, we have exponential decay. So it's sort of like starting, it's rapidly decreasing as the value of x increases. Okay, you don't need to know exactly what these curves look like in the exam in terms of drawing them. You can just draw exponential curve, something like that, exponential decay, something like that. So here's an exercise for you to have a go at. Press pause and have a go. When you're ready, I'll go through it. So A is not an exponential function, or an exponential graph, I should say, because although it doesn't cross the x-axis, it's just a flat line. It doesn't exponentially grow on one side of the axis, so not A. With B, it crosses the x-axis, so it can't be this. C also crosses the x-axis, so does D. Now E, does it rapidly increase after it intercepts the y-axis? Yes, it does. So because it does, and it doesn't cross the x-axis, this is an exponential function. Well, what about F? Now, F doesn't cross the x-axis, and it does rapidly increase, but it should only rapidly increase on one side, not both sides. Okay, so if it increased in the F side, it should be getting close to the x-axis on this side, and if it was increasing as x increases, it should then be getting close to the x-axis on this side. So this is not an exponential graph. So E is the answer there. Hopefully that clarifies exactly what an exponential graph looks like. So moving on to our first example. So the way my videos work, I'm going to do the example on the left. You are then going to press pause and have got the example on the right. Now with this, it's quite straightforward. So we've already gone through something like this. So we can see that the graph crosses the y-axis. When it crosses the y-axis, x we know is 0. So we can just use that knowledge and say y is equal to 0.8 to the power of x. We know x is 0 at that point. So if we put that in, and we get y is equal to 1 because anything to the power of 0 is 1. And it's the exact same thing on this side. So anything to the power of 0 is 1. So before we do carry on, I did say that exponential functions or exponential curves always cross the y-axis at 1. And that is true in the case when the equation is in this format, such as y is equal to 2x that we saw earlier. Because if you put that into here, so we have y is equal to ax, and if you put x as 0, we end up with a to the power of 0, which then gives me 1. Okay, so that's true here. However, on this side, we have y is equal to abx. Now, if I draw the same curve, we have y is equal to abx. Now, x is still 0. That's where it intercepts the y-axis. So we have y is equal to a b to the power of 0. Now, anything to the power of 0 is 1, so you're left with y is equal to a. Okay, so when the equation is written in this format, it does not necessarily mean it crosses the y-axis at 1. It's only when the equation is written in this format that you can immediately know that it crosses the y-axis at 1. So, moving on to an example. So here we've been given a graph and we've been asked to find the equation of the exponential curve. And we've been told what format the curve is in. Okay, so we're going to start off by looking at the first coordinate. So I'll start off with 0, 5. It's normally easier to work with zeros. So if I write the equation of the curve, you have a, b, x. We can see that the y coordinate and the x coordinate is that. So if I substitute that in, we have y is 5. We don't know what a is. We don't know what b is, but we know what x is, 0. Okay, now we know anything to the power of 0 is 1, so we can say 5 is equal to a. So we've already found the first bit the question is asking for. Now we need to find b. So let's look at the second point. We have 2 and 10. We know the equation of the line is y is equal to abx. So let's substitute the x and y coordinates in. We know that y is 10. We know that a, now we know what a is because we found it here. We can substitute that into there. So that is going to be 5 times b, which is, well, we don't know what b is, and we know the power of bx here is 2. So we are left with this equation here. Now we can divide each side by 5, and that gives me 2 here, which is equal to b squared. Sorry, I misread that. That's a 20. So that should say 20. And if I divide each side by 5, I get a 4 here. And now if I square root each side, I get b is equal to 2. So we have now found a and b. Now hopefully you've pressed pause and had a go at the example on the right. So if I zoom into this, again, the exact same principles apply. We start with 0 for coordinate. It's just that it's easier to work with zeros. That's why I start with this coordinate here. A, B, x, substitute in x and substitute in y. And for x, for y, we have 4. A, b to the power of 0. We know b to the power of 0 is 1, so 4 is equal to a. And again, if you do that on the other coordinate, to find the value of b, we have y is equal to a, b, x. We know that y is 36. We've already found a on the left, so that's 4 times b to the power of 2. If I divide each side by 4, I get 9 is equal to b squared. If I square root each side, I get b is equal to 3. So, moving on, looking at another example. So again, the exact same method, 0, 5, to find the equation of the exponential curve. Y is equal to a, b, x. Substitute y in, 5, a, b, substitute that in, that's 0. And anything to the power of 0 is 1, so that means a is equal to 5. And if I look at this coordinate here, we have y is equal to a, b, x. And if I substitute y in, 625 is equal to a, b to the power of 3. We know what a is. We've already found that, so that's 5. So if I divide each side by 5, I get 125 is equal to b cubed. And if I cube root, which looks like this on your calculator, by the way, if I cube root 125, I get b as 5. So a is 5 and b is 5. So hopefully, again, you've pressed pause and had a go at the example on the right. So if I zoom into this, starting with the coordinate on the left again, we have 0, 10. So we can say y is equal to a, b, x. If I substitute the y coordinate in, anything to the power of 0 is just 1, so we know a is 10. If I move over to this side, we have 3 and 640. Again, if I write the equation for the curve that we've been given, it's that one there. Substitute y in. We know what a is, 10. We don't know what b is. We're trying to find that. If I divide each side by 10, I get 64 is equal to b cubed. And if I cube root each side, I get 4 is equal to b. So here's 2 questions for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. Here are the answers. Mark your work. Now moving on, we are now going to look at negative values. So it gets a little bit more tricky here. Because you need to know your rules of indices. So that's minus 3, 64. Well, actually, I'm going to start off with 0 and 27, like I said before. It's just that I know as soon as I raise something to the power of 0, it becomes 1. So it just makes my life easier. So I'm going to start off with that. So substitute the values in. Immediately I found A. Okay, now moving on to this side. Now let's substitute the values in. 64, so that's the y coordinate. A, we've already found as 27. B to the power of minus 3. Now anything raised to a negative power can just be written as 1 over that power. So we can rewrite this as 64 is equal to 27 times 1 over b cubed. Okay, now the negative sign's gone. So we can rewrite that as this. Now what does that mean? That means I can write this as 64 is equal to 27 over b cubed. I can move the b cubed to that side and the 64 to this side. So that means b cubed is equal to 27 over 64. Now if I cube root both of these, so we can say that b is equal to the cube root of 27 over the cube root of 64. And the cube root of 27 is 3 and the cube root of 64 is 4. And that is your answer there. So again, hopefully you've pressed pause and had a go at the example on the right. So if you start off with the 0, 16 again, because it makes life easier. So we have y is equal to a, b, x. We have 16 is equal to a, b to the power of 0. So 16 is equal to a. Nice. So if we move over to the right, we have minus 2 and 81. We have y is equal to a, b, x. Y is 81. A is 16. B is negative 2. And we can write that as 1 over. So I'm just going to skip that step here quickly and just write that as this. Okay. So now I can swap these two around. And that then becomes b squared is equal to 16 over 81. And now I can say that b is equal to the square root of 16 over the square root of 81, which is 4 over 9. So here's 2 practice questions for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. Here are the answers. Mark your work. Now moving on, now we have a non-zero coordinate. But again, the exact same principles apply. I'm going to start with 3, 10. Okay, so we have y is equal to a, b, x. As usual, substitute the coordinates in. So 10 is equal to a, b cubed. Okay, we'll stop there. Let's look at the other coordinate, because there's nothing else we can do there. So we have y is equal to a, b, x. We have y as 40. A we still don't know. And we have b as we don't know. And x here is 5. Okay, so now we've got 2 equations. And we've got 2 unknowns in both of them. Now, because both of these points lie on the same line, we can rearrange one of them for a. So I'm going to take a look at this one here because the numbers are smaller. So I'm going to rearrange this for a, and I'm going to say, move the b cubed there, and I'm going to say a is equal to 10 over b cubed. Now I'm going to take this a, and I'm going to substitute that into there, and you'll see what happens. 10 over b cubed times b5. Now we've just got 1 unknown in this equation, rather than 2, and the only unknown now is b. So now with the laws of indices, when you're dividing indices, so essentially these 2 are being divided here, so we can cancel that, and that becomes to the power of 2. We can do 5 minus 3 there, so that is 40 is equal to 10 times b squared. Now if I divide each side by 10, 4 is equal to b squared, and if I square root both sides, that's b is equal to 2. Now that we have b is equal to 2, we still don't know what a is yet, but we can use this value, substitute that into there, and we have a. So that means a is 10 over 2 cubed, and 10 over 8 is equal to a. We can simplify that half that to 5 over 4. So that was that. Again, hopefully you've pressed pause and had a go at this one. So starting with 2 and 3, we have y is equal to a, b, x, and we have 427 here. And then if I substitute the values in, 3ab squared, and then here we have y is equal to abx, because it's another point along the same line. Substitute that in. Now rearrange one of them for a. I'm just going to do this one here because it's got smaller numbers. And now substitute that into this equation. So that's 27 is equal to 3 over b squared times p4. Again, laws of indices. That becomes 27 is equal to 3p squared. Rearrange that. That's 27 over 3 is equal to b squared. And that simplifies to 9 is equal to b squared, which means b is equal to 3. which then means I can take that value, put it back into here. So that means it's 3 over 3 squared is equal to a, and that just becomes 1 over 3 is equal to b. So again, here's 2 practice questions for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. Here are the answers, mark your work. So now we're looking at negatives. So again, things get a little bit more trickier with indices when you have negatives involved. So we're going to start with the negative 1, 2. So y is equal to a x. So y here is 2. We have a, and then b to the power of minus 1. And then we have minus 2 and an 18. And then we have y is equal to abx again. And then we have 18 is equal to a b to the power of minus 2. So I'm going to rearrange one of these equations for a. I'm going to do the one on the left. Now remember, when there's a negative indice, it's the same as writing 1 over that indice to the same power. So since here the power is 1, we can say 2 is equal to a over b. Okay, all I've done is I've rewritten this as 1 over b. Now if I rearrange this, that means 2b is equal to a, which then means I can write here 18 is equal to 2b times b to the minus 2. Now when you multiply indices, it's the same as adding their powers together. So I can say that 18 is equal to 2b to the power of minus 1. I can write that as 18 is equal to 2 over b. And I can swap these two around, and I can say that b is equal to 2 over 18, and I can simplify that to 1 over 9. Now that I know that's 1 over 9, I can sub that in there. So I can say 2 times 1 over 9 is equal to a. So 2 over 9 is equal to a. So again, hopefully you've pressed pause and had a quick example on the right. So again, if we start off with minus 4 and 3. So y is equal to abx. We know that y is 3. And I'll just rearrange this now so it's quicker. I can just write that there. And 3b4 is equal to a. Again, just using the laws of indices there. And on this side, we have 7 and an 81. Y is equal to a bx. And then that becomes 81 is equal to a b to the power of minus 7. Now, if I substitute a into there, that becomes a t1 is equal to 3b to the power of 4 times b to the power of minus 7, which then becomes 81 is equal to 3b to the power of minus 3. And I can write that as 81 is equal to 3 over b cubed. And if I swap these two around, that becomes b cubed is equal to 3 over 81. And now all I need to do is cube root these two. And I know that I can simplify this further into 1 over 27. And then if I do b is equal to the cube root of 1 over the cube root of 27, that gives me 1 over 3. So now what I know what b is, I can just put that into here. So that means 3 times 1 over 3 to the power of 4 is equal to a. And that just becomes 1 over 3 cubed, because that 3 cancels out, and that's 1 over 27 is equal to a. Here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers, mark your work. And now we're looking at, well, how do you find a missing coordinate? So with this one, there's no point starting with this here because it's already missing a coordinate anyway. So it's better to start with a coordinate where you know both values, x and y. So let's start with 4, 5 and take it from there. So if I have 4 and 5, again, the equation is y is equal to abx. Let's substitute the values in. So 5 is equal to ab to the power of 4. Let's look at the next coordinate. That's 6 and 45. That's y is equal to abx. So we can substitute the y. And now at this point, you should notice that, well, we've got 2 unknowns on both sides. We should rearrange one equation. So if I rearrange the one on the left, I end up with 5 over b to the power of 4 is equal to a. Now if I substitute that into the equation on the right, and now if I use the laws of indices, I can do 6 minus 4 there. So that's 45 is equal to 5b to the power of 2. And if I divide each side by 5, that means 9 is equal to b squared, which means that b is equal to 3. Now I know what b is, I can find a. So a is going to be 5 over 3 to the power of 4. I'm going to leave that as that for now. And now if I go on and look at the last coordinate, I have -1 and k like that. So if we write that same formula out, y is equal to a, b, x. Well, what is y? K. Okay, and what is a? Well, we know a is 5 over 3 to the power of 4 times what is b? 3, and what's x? -1. So that then becomes k is equal to 5 over 3 to the power of 5. I'm going to leave that in that form. But yeah, that'll do. Now again, hopefully you've pressed pause and had a good example on the right. Again, you know, you're looking at this, you should immediately be like, well, there's no point starting here because I don't know what x and y is. So I should either start with this or this. I normally start with find it easy to start with the smaller numbers, so 2 and 3. And rearrange that for a. And moving to the next coordinate. And if I substitute the value for a in here now, and if I use my laws of indices, if I rearrange that, divide each side by 3, square root each side, cool, and now I can find a because I know what b is, so 2 squared. 2 squared is 4, so I know 3 over 4 is a, and that's what b is. And we've got this final coordinate here, -1k. And again, just substitute the values in. We know y is k, a is 3 over 4, b is 2, and x is -1. That is k is 3 over 4 times 1 over 2, which is 3 over 8. Again, here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers, mark your work. And finally, we're going to wrap up by looking at a real exam question. So feel free to press pause and have a go at this yourself. So again, we're looking for this value here. It's always sensible to start with what you do know, and I always love to start with values where x is 0, because that just makes your life a lot easier. Anything raised to the power of 0 is just 1. So if I start off with that value there, so we have 0, 8. Let's use our equations. We have p, q, x. Let's substitute the values in. 8 is equal to p, q, x is 0, so this becomes 1. So we know now 8 is p. Okay, so we figured that bit out. Let's move on to the next coordinate. It's 1 and 18. Let's use that same equation, p, q, x. So y is 18. We know what p is, 8, q, and the power is 1, which is nice. So that just means that 18 over 8 is equal to q. We can simplify that. So half that, 9, half that, which is 4. So now we have the value for q as well. And moving on, we are now looking at the final bit, which is 1.5. K. So again, the exact same thing. Substitute y in. P we know is 8, q we know is 9 over 4, and x we know is 1.5. Now, if this was on a calculator paper, you could just type it into the calculator, but if this was a non-calculator paper, you can write 1.5 is the same as writing 3 over 4. Sorry, 3 over 2. And then essentially what you're doing is square rooting the two values inside. So that then becomes 3 over 2, and then you're cubing the values. So that then becomes k is equal to 8. So square root of 9 is 3. And then if you cube root that, that's 27. And the square root of 4 is 2. And if you cube root that, that's 8. And then you're left with the value of k as 27, because the two 8s cancel out. So if you found that video useful, I've got loads of other content like this on my YouTube channel. And as always, I'll catch you in the next one.